Yes, dear students, in the series of numerical physics, we are continuing with the numerical which is based on the magnetic field. Now, we'll go through this numerical. इस न्यूमेरिकल को हम देखें, a proton enters into a magnetic field of 2000 Gauss directed along x-axis. Calculate the force acting on the proton of velocity if velocity of proton is 0. This is the first. If velocity of proton is 0. Second part, if the initial velocity of proton is 4 into 10 raised to the power 7 meter along y-axis, and if the initial velocity of the proton is 4 into 10 raised to the power 7 meter per second along x-axis. Now, if we go through the force on a charged particle which is moving in a magnetic field, इसको हम कैलकुलेट कर सकते हैं b q v sin theta, where b is the magnetic field, q is the charge, v is the velocity, and theta, this theta is the angle which the velocity of charge is making with magnetic field. So here, if we go through this, suppose it is x-axis, say it is y-axis and it is z-axis. Now the magnetic field is acting in this direction. Magnetic field is direction like curly x according to this. So the velocity component, calculate the force acting on the proton if velocity of proton is 0. So first case को हम देखें तो यहाँ velocity is equal to 0 दिया हो, मैग्नेटिक फील्ड x डायरेक्शन में एक्ट कर रही, प्रोटॉन जो है, प्रोटॉन का मास, प्रोटॉन का चार्ज हमको पता है 1.6 into 10 raised to the power minus 19 coulomb, and it will be having a plus nature, positive nature. So if we go through this, we will have force which is acting on this proton when it is entered in the magnetic field in x direction. A, the velocity is 0. So no force will act upon. This is the first answer. Okay. Now, if the initial velocity of proton is 4 into 10 raised to the power 7 meter per second along y-axis. Now this charge is moving, this positive charge now is moving in this direction. Velocity is this, and this is the 90 degree. Angle is of 90 degree because the magnetic field is in this direction, in x direction, and the proton is moving in the y direction with the velocity. So if we go through the second part of this question, so velocity which is given to us 4 into 10 raised to the power 7 meter per second, charge which we know very well, q is equal to 1.6 into 10 raised to the power minus 19 coulomb, and velocity which is we have already calculated velocity, theta is 90 degree, sin 90 is 1, sin 90 की वैल्यू आपकी 1 है. So force आपका आ जाएगा magnetic field, that we have to convert it into, now magnetic field which is given to us 2000 Gauss, we will convert it into Weber per meter square. So it is 0.2 Weber per meter square. If we take this 2000 divided by 10,000, so it is 0.2 Weber per meter square. So the magnetic field which we have here, this is B 0.2, Q is 1.6 into 10 raised to the power minus 90, and velocity is 4 into 10 raised to the power 7, and sin 90 is 1. So if we calculate the force, it is 10 raised to the power minus 12, minus 19 and 7, 0.2, 3.2, it is 0.8 into 1.6, 250 times. So it is 10 raised to the power minus 12 Newton. The force which is acting, that is 1.6 into this is 0.2. So it is yes 1.28. The force which is acting. When now the force which will be acting in this case in this z direction means it is perpendicular to both. So the force acting in z direction. Now third case, we will talk about the third case. I am taking it here. If the initial velocity of proton is 4 into 10 raised to the power 7 meter per second along x-axis. Now along x-axis means both are in same direction. Theta will be 0. Now the sine 0 is 0 and the force, that is b cube v sine theta, again it is going to be equal to 0. So no force will act upon it. So when the proton is moving in the direction of the magnetic field, means the velocity of this proton is in the same direction of the magnetic field, it is going to be equal to 0. So no force will act upon. So this way we can determine by using the formula F, and if we know all the components, we can determine. यहाँ पर हम वैल्यू निकाल सकते हैं F is equal to b q v sin theta. We have converted magnetic field which is given in Gauss. So this way we can do the numericals. Okay.